Welcome back. So in this lesson, we're going to build on a previous example where we created our particle system or our group of agents. That's another way of thinking about it. And we'll talk about, we'll give an example how we could build some kind of visual structures on top of this framework. Let's get right into it. So I'm starting here with the last program that we had in the previous example. And again, I'm going to remix it so we have a bit of a trail here. And we can see the different versions leading up to this this example. So I'm going to remix it, and let's call this agent trail, and let's call this drawing machine built on a particle system. Okay. All right. So just to recap here, this is what we're working with. We've created this array called group, and inside of it we store these objects called we call agents. So what an agent is just a variable that contains a position, a velocity, an acceleration, and then we've also added the concept of a lifespan, which means when it gets when it runs out of life, we delete that agent from our group. We also delete the agents from the group when they get outside the boundaries of the screen, and we do this inside the cleanup function. So if we want to turn this into some kind of drawing machine, just like what we've done in the examples so far in the series, we can just start to think about, what is the framework we've created? What are we working from here? What we have is a bunch of points that are being animated over time. In previous examples, we use randomness and parallel noise. In this case, we've created a simple animation system using vectors. So let's see what kind of interesting drawing ideas we could come up with to build on top of this system. For example, one thing we can point out here is that one thing we can do with the background, in the previous lessons we talked about creating a recorder object to record trails. We're not going to do it in this one for simplicity, but we could do that also. If we put an alpha value in the background, we're going to see those trails over time that are already going to start to hint at maybe some of the possibilities we can have for drawing with this particle system. So the first thing we'll do is first we're going to get rid of this number here because we're no longer interested in that. We know that the group is shrinking over time. So let's add a user interface so we can start to tweak some of these variables a little bit more easily through the interface. So things we might want to tweak might be the amount of gravity here, the damping, if we want to experiment with that. In this example, I'm going to get rid of the follow mouse behavior. We're not going to use it, so we can always get it back from previous examples. And I'm also going to get rid of the easing as well at the same time because we don't need it anymore. But I will keep damping around. So things we might want to tweak, right, would be maybe the alpha value of the background. Let's create a variable for that. Let's call it background alpha. And then background alpha. And we're going to create a GUI to be able to change these variables. So we're going to use dat.GUI. Remember, we have dat.GUI as part of our libraries that we're including in our template, so we don't have to do anything. And what am I doing here? I'm going to call this GUI, and then to create it, I'm going to say GUI equals new dat.GUI. And the way dat.GUI works is we're going to give it an object. We're going to use an object that's going to contain all the parameters we want to be able to tweak over time. So that object's we're going to call it settings because it makes sense to me. So inside settings, it's an object, right? So we're using the curly brackets here. It means we're going to be able to define variables using a name and value pair like this. And then we're going to use let me just rewrite it again. We're going to use a colon to separate them. And then let's call this guy gravity. Now here, dat.GUI doesn't have a user interface element to actually change a vector directly. So what we're going to do is we're going to store the gravity as this value over here. And then in draw, we're going to say create a vector called gravity using 0 and then settings.gravity. And we're going to recreate that vector in every frame because we might change that value as the program runs. So we want to be able to update what the gravity is over time. Column, not a semicolon. And then what's the other thing we could also put in there? Oh, maybe the lifespan of our agents. That could be an interesting one to play with. So let's add lifespan as a setting. So once we've put these variables into settings, if we want to use them in dat.GUI, what we do is we say GUI.add, and then we say settings. Then we say the name of the setting we're interested in, and then we're going to give it a range here. So let's say this is going to go from 0 to 1. So this is going to become the damping. GUI.add settings, background alpha. It's going to be from 0 to 255. Oops, 0 to 255. Then GUI.add settings, gravity. Let's say gravity, I don't know. We can always experiment with this. Going to go from smaller than we have it now to bigger than we have it now. And we can always go back and change these ranges. And then the last one is going to be lifespan, right? So lifespan is going to vary, let's say from like really short life to much longer life. I'm just kind of making this up as we go. And it's nice that dat.GUI just puts in the default value to be whatever we have in our settings. And then if we want to use these values in our program, we just have to refer to the settings object. So here, when we create a new agent, we're going to say, instead of 300, we'll say settings.lifespan. And then in background here, we'll say settings.background alpha. And then when we refer to the easing, where was that? The damping over here, right? Damping, we're going to say settings.damping. So now if we create objects, we can actually go and play with the gravity, right? We can make it really, really small. Actually, it'd be nice if we could go to zero gravity. So let's do that. 0 gravity, right? And then we can add gravity. We can make it tense. We can change the background alpha value so we can have, trails. If we go too far, like close to 0, the effect is that over time we're still going to see residue of these trails. It's not a really perfect effect, but it's good enough for this example, just so we can kind of draw over time, or we can just not have that effect at all. We can play with the damping. I mean, the damping, if we reduce it by even a little bit, like objects just start to fall right away. So let's tweak this damping. This is not a very useful range. We're going to go from 0.9, even 0.95 to 1. So we're going to set some useful boundaries here so that this slider is a bit more useful. Okay. All right, so we've created a GUI, right? And already we can play with this. We can also add the twitch amount in there. I'm going to leave that to you as an exercise. If you're interested, you could try to do that. But already we have some possibility to create a drawing machine. For example, we could lower the background quite a bit, and then we have this sketch, right? It's kind of interesting. We have this explosion of particles coming from the center. Let's give ourselves also maybe a little bit more flexibility. So instead of always having these agents come from the center, let's make them emerge from the mouse cursor position, let's say. So let's do that when we create a new agent. So over here, when we create a new guy, instead of width over 2 and height over 2, which is a center, which might be what we want, but let's just experiment here. Let's replace this with mouse X, mouse Y. So now when we move our mouse around, we can actually change the location where the agents are first created. So they're kind of just following our mouse cursor. And again, we can reduce the background. Maybe I'll play around with this. Here's another interesting experiment here. So now we've kind of created a bit more of a drawing tool, I guess, because it's following the cursor. Let's see. Or we could get rid of the gravity altogether, and create, these little pockets. Other interesting things we could do, for example, in render, we could decide to, let's say, if agent.lifespan is 0, let's draw like a circle, I don't know, at their position. And then let's not erase the background. So we can experiment with the framework that we have here and come up with sort of different mappings for these coordinates. Another interesting thing we could try would be, let's see if we can move away from just drawing these agents directly. For example, we could say, let's connect them with lines, right, to see what happens. Maybe we can use these agents to create this kind of web-like pattern that then we can use to draw over time. So if we wanted to connect them with lines, for instance, we might do something where, okay, here is where we are doing our simulation, okay? And then draw lines connecting the agents. So we're going to create 2 for loops, right, so that we can compare every agent with every other one and then draw a line between them, let's say. So let's write for loops like this, not int, sorry, let. We're going to say use I, right? Going to count from 0 to the number of agents in the group. And then we're going to create j. Group.length, j++. And then for simplicity here, let's do something similar we've done down in the is inside the box function. So I'm gonna put the values of the x coordinate of these agents into some variables, so that I don't have to always write, the long form. Let me show you what I mean. So for example, the first agent would be, let's call it x1, right? It would be group bracket I dot position dot x. And then y1 is going to be group bracket I dot position dot y. And then x2, same thing. This is going to be bracket j. And then y2 is going to be bracket j. So what I'm doing here is taking the coordinate of one agent, right, and then the coordinate of another agent. And the first one is going to be the index determined by this for loop, and then the other one is going to be the index determined by that for loop. Now, because they're nested, it means that these 2 for loops, just like when we had the grid idea, right, are going to go through all the pairs of coordinates that exist between 0 and group.length. So it's giving us all the combinations of I and j. Now, we don't want to draw a line to ourselves, so we're going to do, before we do a test here, we're going to do a little check. We'll say, as long as I is not the same as j, right? Because then we will be drawing a point. So we want to make sure these 2 indices are not the same. And then if that happens, we're going to draw a stroke. We're going to do a line. Oh, sorry. I meant not a for loop here. I was wondering why this didn't work. I meant to write an if statement. So we're going to say if, right, these 2 indices are not the same, we're going to connect our objects with a line. All right, so this is a pretty slow now because we've created a whole bunch of objects at once. And we're connecting everybody with everyone. Okay? So that's creating a really dense set of lines. So let's refine this a little bit. First, it would be nice if we could maybe change the stroke alpha. So let's turn that into a parameter. Let's call this FG alpha for foreground and background. Or actually, let's just call it stroke alpha so we know what we're talking about here. And in this code here, we're going to set a stroke, a white stroke, and then we're going to set the alpha based on this value so that we are able to change it if we want. Let's say 128. Sorry, this would be settings.stroke alpha. Okay. So now it's got some transparency, and then let's also add it to the GUI. So we'll give it the same range as the background. So now we can choose to make this more or less transparent if we want. All right. So now this is still too many lines, so let's refine this further. Right. So there's a couple of improvements we can do. One improvement we could do right away here is be a little bit smarter with our for loops. Now, one thing that's happening is we're comparing every object with every other object. And as a result, sometimes we're going to do each comparison. Twice, because if you think about a grid, right? If we forget about the diagonal in a grid, this is when I equal j. There's only sets of unique pairs on one half of the grid. Okay? So we're going to work around this by saying this inner loop, instead of starting from 0 every time, we're going to start from I. And that's what that's going to accomplish, it's going to eliminate, right, redundant comparisons. It's going to say count through all the objects here, but then in the inner loop, it's going to know that we've already made some of these comparisons in the past. So we're going to start counting from the index I instead of from 0 every time. And if you picture this visually, what it translates to is we're only looking at one half of the grid instead of the whole grid. And already this is going to be a little bit faster, at least on my computer, because now we've kind of cut redundant lines, whereas we would be drawing every line twice before. The other thing we can also look at is, let's look at the distance between these points, and maybe we'll only connect them by a line if they are close enough. So let's say if the distance between these 2 points, right? If it's, let's say, smaller than 50, then we're going to draw a line. So that's a lot more manageable. So only the objects that are close together are going to get connected, and then the ones that are further apart are not. So now we have fewer lines here. So this is starting to look pretty interesting. So let's refine it a little bit further. There's going to be a lot of redundant lines here if I'm pressing really, really close as well. So maybe we'll set this distance to be a range instead. So let's put the distance into a variable, like so. And then we'll say if d is smaller than, we can make it a little bigger, 75, and greater than, let's say, 20. So that it won't draw a line if it's really, really close, right? It has to be between 20 and 75. Just for our purposes here, let's comment out the bit of the code where we're rendering the agent itself, the little box. We're just going to comment it out here in the for loop. so that all we see are the lines. Yeah. That's kind of neat. So let's play with these settings a little bit more. So here maybe maybe those lines are a little bit long, so there's too many of them. Let me change how this is assessed here. We'll say greater than 10 and smaller than 50. All right, so this feels a little bit more dynamic to me. Again, we could experiment with this setup. Maybe we'll just get rid of the background altogether and then make the stroke even lighter. You could see what happens if we get rid of the gravity. If we want to erase here, I'm going to make the background again 0. Here, let's tweak some of these settings permanently. We'll make 0 for our alpha background, our stroke 60, and let's put a gravity of 0 as a default. And then in setup, let's put our gray background here and a gray background here. Also, so that when we resize the window, it will erase what we started with. All right, so let's leave it at this for this lesson. I'll see you in the code exercise video where I'm going to explain what I want you to work on this week. So I'll see you there.